A rectangular beam has a base of 300 mm and effective depth of 490 mm, specified compressive strength of concrete and the yield strength of steel reinforcement is 27.60 megapascal and 276 megapascal respectively. Calculate the required steel area for tension if the factored moment or MU is A 20 kilonewtons meter and if the factored moment MU is 140 kilonewton meter. Okay. So, para ma-solve natin yung specific problem na ito, sulat muna natin yung mga given. So, meron tayong beam base na yung base niya ay 300 mm. Yung kanyang effective depth is 490 mm. And then yung F'(C) natin ay 27.60 megapascal. Okay, so if yung F'(C) natin is less than 27.60, therefore yung beta 1 factor natin is automatically ay 0.85. Okay. Next, yung yield strength of steel reinforcement ay 276 megapascal. Calculate the required steel area o yung AS. Yung required natin ay AS. If ang mga factored moment natin ay 20 kilonewton meter tsaka 140 kilonewton meter. Okay? So, before natin isolve yung problem, i-check muna natin if singly reinforced beam yung type of problem na ito or doubly reinforced beam or any beam section. Kumbaga, i-check muna natin kung anong specific design problem to. Okay? To do that, kuhanin muna natin yung moment capacity or maximum moment capacity. So, kuhanin muna natin yung maximum moment capacity or MN max, wherein meron tayong specific or direct formula na reduction factor multiplied by 51 over 140 beta 1 factor F'(C) BD squared and 1 minus 3 over 14 of beta 1. So, ito yung ating direct formula for the maximum moment capacity. Okay? So, meron na tayong beta 1, meron tayong F'(C), meron tayong BD. So, wala na lang tayo is yung reduction factor. Okay? So, kung matatandaan natin, yung ating tensile strength maximum is 800 megapascal. And as we discussed, na if the tensile strength is less than or equal to 400 megapascal, that means we are on the compression controlled section. Okay? And if our tensile strength is greater than 1000 megapascal, we are on the tension controlled section. Okay? However, between the 800 or between the 400 and the 1000, we are on the transition region. Okay? So therefore, we need to compute the reduction factor since nasa transition control tayo or nasa transition region. Okay? Kasi kapag nasa compression control tayo, yung reduction factor natin ay 65. Whereas kapag yung tensile strength naman natin or nasa tension control tayo, yung reduction factor natin ay 0.90. So since yung tensile strength maximum is 800 megapascal, at ito ay nasa transition region, kailangan muna natin i-compute yung reduction factor na merong equation na 0.65 plus 0.25 quantity Fs minus Fy over 1,000 minus Fy. So kapag sinubstitute natin ito, reduction factor is equals to 0.65 plus 0.25 multiplied by yung Fs max natin at 800 minus yield strength natin na 276, divide natin ng 1,000 minus 276 din. Therefore, yung reduction factor natin dito ay 0.831. So ito yung ating reduction factor. Okay? So since kompleto na yung mga given, substitute natin yung value to determine the maximum moment capacity. So Mn max is equals to the reduction factor of 0.831 multiplied by 51 over 140. Beta 1 factor natin na 0.85. F prime C natin na 27.6. Base na 300. And 400 na effective depth. Naka-squared yan. Quantity 1 over 3 over 14 ng 0.85. So yung magiging result natin dito is in terms of Newton millimeter. Okay, so if yung gusto natin is in terms of kilonewton meter, since naka-kilonewton meter yung mga factored moment natin, so divide natin ito ng 1 times 10 raised to 6 or divide natin yun ng 1 million. Okay, so therefore yung ating maximum moment capacity is 418.371 kilonewtons per meter. So ito yung ating pang-check sa mga factored moment na given. Okay? Next. So yung unang tanong muna natin na kailangan i-resolve if or is this type of problem is a singly reinforced beam problem. So to do that, i-compare natin yung factored moment versus sa maximum moment capacity. Okay, if mas malaki yung ating maximum moment capacity, therefore nasa singly reinforced beam type problem pa tayo. Whereas kapag mas malaki naman yung factored moment compare sa ating maximum moment capacity, therefore nasa doubly reinforced beam type of problem tayo. Okay? So solve natin yung letter A. 20 or mu is 20 kilonewtons per meter, wherein ito ay less than 2 maximum moment capacity. Therefore, yung type of problem natin is singly reinforced beam or SRB. Okay? So after natin ma-check if it is a singly reinforced beam type of problem, compute naman natin or check natin if yung section natin if it is on the tension controlled or nasa transition region yung ating MU. Okay? So to do that, para i-compare natin if nasa tension control tayo or hindi, kailangan muna natin i-compute yung moment capacity under tension control. Okay? So compute muna natin yung moment capacity under tension controlled, na meron tayong direct formula na 459 over 1,600 beta 1 factor f prime c bd squared quantity 1 minus 3 over 16 of the beta 1 factor. Okay, kung mapapansin ninyo, yung ating maximum, yung ating tension controlled moment capacity is wala na siyang reduction factor. Okay, kasi dito sa direct formula ng ating tension controlled moment capacity is consider na natin na yung ating reduction factor is 0.90. So wala na tayong i-compute pa dyan na reduction factor. Okay, so isi-check natin kung if it is indeed tension controlled ba tayo or hindi. So lagyan natin ng note. If yung ating tension controlled moment capacity is greater than to the factored moment, therefore ito ay nasa tension control. And if tension control, therefore yung reduction factor natin is 0.90. Whereas kapag naman yung tension controlled moment capacity is mas maliit compare to MU, therefore tayo ay nasa transition region. And kailangan natin i-compute separately yung ating reduction factor. Okay? So going back, yung ating tension control moment capacity is 459 divide 1,600 multiply by 0.85. F prime C natin na 27.60. Base natin na 300 and effective depth of 490 squared. So 1 minus 3 over 16 of 0.85. So ito pala ay 490. This one is 490. So, pre-calculated naman itong problem ito. So, tama naman yung ating sagot dito. So, going back, yung ating tension control moment capacity, if kinompute natin yan, yung sagot dyan, and if gusto natin is in terms of kilonewton meter, divide na natin yan ng 1 million. Okay? So, we have 407.508 kilonewtons per meter. And it is greater than sa ating factored moment. Therefore, tension control. And if tension control, reduction factor natin is 0.90. Next, after satisfying series of checking, after natin malaman na ito ay singly reinforced beam, at the same time it is a tension controlled section, pwede na natin mag-proceed para malaman na natin kung ano ba yung tinatanong talaga, which is yung required tensile or required steel area. Okay, to do that, kailangan natin i-compute yung coefficient of resistance or Rn. Tapos, compute yung steel reinforcement ratio and etc. Okay? Para ma-compute natin yung Rn o yung coefficient of resistance, kailangan gamitin natin yung ating factored moment. Equate natin yan sa reduction factor, coefficient of resistance, multiply by the base and then the squared of the effective depth. Okay, so since yung MU natin, the first na pinapakonsider ay 20 kilonewtons meter, so yung mga value dito is naka-millimeter, so i-reciprocate natin yung ginawa natin kanina. Kung dito is dinivide natin ng 1 million para maging kilonewton dash meter, para maging naman newton per millimeter, i-multiply ngayon natin siya ng 1 million or times 10 raised to 6. Bakit? Kasi yung mga given natin dito ay in terms of millimeter. So, yung magiging result dito is in terms of megapascal or newton over millimeters squared. Okay? So, we have 20 times 10 raised to times 10 raised to have 20 times 10 raised to 6 equals reduction factor natin. Dahil nasa tension control tayo, meron tayong reduction factor na 0.90 multiplied by the coefficient of resistance multiplied by sa kanyang dimension na 300 times 490 squared. So, yung ating coefficient of resistance is 0.3085 megapascal. Next, after natin ma-compute yung coefficient of resistance, pwede na natin gamitin yung formula ng area or steel reinforcement ratio, dahil yung steel reinforcement ratio is area of steel reinforcement over the dimension of the section. So, if meron na tayong rho at meron na tayong dimension, makukompute na natin ngayon si area of steel reinforcement. Whereas, si rho is meron din siyang direct equation na 0.85 F prime C over Fy quantity 1 minus square root of 1 minus 2 Rn 0.85 F prime C. Okay, so substitute natin yung steel reinforcement ratio na 0.85 F prime C of 27.60 divided by 276 megapascal, quantity 1 minus the square root of 1 minus 2 times 0.3085 over 85% ng F prime C na 27.6. So, yung ating rho ay 0.00113. Okay? So, dito natin siya gagamitin. Okay? But, bago natin gamitin si rho, i-check muna natin yung kanya mga minimum at saka check natin if pasok ba siya sa minimum. Okay? So, yung minimum natin is either 1.4 Fy over Fy or square root of F prime C over 4 Fy. Tingnan natin kung alin yung mas malaking value dito. So, 1.4 divided by Fy na 276, meron tayong 0.00507. And dito naman, square root of 27.6 divided by 4 times 276, we have 0.00476. So, between these two minimum steel reinforcement ratio, pipili natin yung mas malaki. So, by this equation, ito yung mas nag-prevail or 0.00507. Okay, ito yung compare natin sa rho. Okay, so since yung rho natin, ito yung pinaka-minimum, therefore, kailangan hindi dapat bababa dito yung steel reinforcement ratio na gagamitin natin. Okay, so yung rho na na-compute natin is 0.0013. whereas yung minimum is 0.00507. So kung titignan natin, mas malaki pa yung minimum compared dun sa actual raw na nakuha natin. So therefore, yung gagamitin natin na steel reinforcement ratio is the minimum or 0.00507. So kailangan, very important na alam natin yung mga minimum or mga limits, kumbaga ng mga parameters na kino-consider natin. Okay? So since raw min is mas malaki pa compare sa raw, therefore, gagamitin natin yung use raw min. Okay, raw min is equals to area still required over the dimension of the section. So we have 0.00507 area of steel reinforcement required multiplied by the dimension of 300 times 490. So cross multiply this equation, we have the required steel area is 0.00507 times 300 times 490. So yung AS natin is 745.29 square millimeter or millimeter raised to 2. So ganoon isolve yung area steel reinforcement required. So that is for question A pa lang. Okay. So if yung ating factored moment is nasa 20 kilonewton meter. If yung factored moment natin ay 20 kilonewton meter, yung ang magiging steel area required natin for tension after series of computation ay 745.29. Okay. Next. So kung yung MU natin or yung factored moment is 140 kilonewton meter, ano yung ating area of steel reinforcement required. So katulad nung letter A, so kailangan i-check muna natin if singly reinforced beam siya or double reinforced beam. So ko-compare natin siya sa maximum moment capacity, whereas na-compute natin kanina na 418.371 kilonewtons per meter. So since mas malaki yung maximum compared sa MU, therefore SRB tayo or singly reinforced beam. Okay, after natin ma-check kung SRB or DRB yung ating section, check naman natin yung if tension control ba siya or transition. Okay, so again, yung nakuha natin kanina na tension control moment capacity is 407.508, which is again greater than compared to MU. Therefore, we are tension controlled or tension still will yield. And yung reduction factor natin is 0.90. Okay, so after natin malaman na ito ay SRB, the same time TSWY or tension still will yield, pwede na natin makompute si coefficient of resistance para makuha natin yung reduction factor at the same makuha yung steel reinforcement ratio and then yung area still required. Okay, so to do that, we have MU is equals to the reduction factor Rn BD squared. So MU natin na 140, so times 10 raised to 6 para maging Newton dash millimeter, and reduction factor na 0.90. Yung Rn natin or coefficient of resistance, which is the unknown, multiplied by 300 and the squared of the effective depth. So after we distribute the given, yung ating coefficient of resistance is merong value na 2 point, meron siyang 2.1596 megapascal. Next, check natin or kuhanan na natin yung area or steel reinforcement ratio na 0.85 F prime C over Fy quantity 1 minus square root of 1 minus 2 Rn over 0.85 F prime C. And after natin masubstitute ito, makakakuha tayo ng steel reinforcement ratio na 0.00822. Okay. After malaman natin yung steel reinforcement ratio, check natin sa minimum. So since hindi naman nagbago yung ating mga parameters, yung mga material properties, yung raw minimum natin is 0.00507, which is mas maliit na compare sa ating raw actual, okay, or steel reinforcement ratio. Hence, i-check naman natin if pasok naman siya sa maximum, okay, which is yung maximum reinforcement ratio is 3/7 quantity 0.85 F prime C over Fy. So, if we substitute the material properties, makakakuha tayo ng 0.03643, wherein pasok siya sa mga limits natin. So, rho min is less than 0 and this rho is less than rho max. Therefore, it is indeed tension controlled. At the same time, yung gagamitin natin na area of steel reinforcement ratio or steel reinforcement ratio is 0.822. Okay, so area natin is 0.00822. Area still required and the dimension of 300 times 490. So yung AS natin ay 1,280 or 1,208.34 square millimeter. Okay, so ganun lang mag-compute ng required steel area using these parameters.